Hello and welcome to practice for chapter 9. Okay, in chapter 9 we're graphing polynomials and rational functions. Let's begin. Number 1, graph the function identifies zeros and the y-intercept. Okay, so this is already given to us in a factored form. So what we want to do is take each of these factors, set it equal to 0, and then solve for x. Okay, these will give us our zeros for the function. Okay, so we know very clearly that this will be x equals 1, this x equals -2, and x equals +3. Right, we're just solving each of these like it's a mini equation. Okay, so now when we go to graph this, let's set up a sample graph on the right. We want to find out where we know where the zeros are, and we also want to know what's happening around those zeros in terms of the graph. Okay, so we know right now that when we go to -2, we have a 0. Okay, so -2 has a 0. +1 has a 0. And +3 has a 0. So now our goal is to figure out what's happening to the left of the leftmost 0, what's happening in between each 0, and what's happening to the rightmost region of the rightmost 0, I should say. Okay, so what we're going to do is test some points, right? We're going to figure out, okay, to the left of -2, we have -3. So we make a little XY table. So we're going to plug in values for -3. This will represent what's happening to the left of -2. In between -2 and +1, we can plug in. I'm going to plug in a different point than 0 because that's going to help us with the y-intercept. I'll plug in -1. In between the 1 and the 3, I'll plug in 2. And then in between, well, after 3 would come 4. Okay, and so very clearly we just plug into our original function. Okay, so we're doing basically f of -3. So -3 minus 1, -3 plus 2, -3 minus 3. Okay, simplify this, -4, -3 plus 2, -1, and -3 minus 3, -6. Okay, multiply it together. That's +4 times -6, so -24. Okay, let's next plug in -1. Okay, so same idea. -1 minus 1, -1 plus 2, -1 minus 3. It can get a little tedious, but it's important when you're doing this without a calculator, without any technological assistance, to really focus on, the mechanics of it all. Okay, -1 plus 2, -1 minus 3, -4. Multiply it all together, it's a +8. Okay, plug in 2. So f of 2, 2 minus 1, 2 plus 2, 2 minus 3. We get 1, 4, and -1. So -4. And then f of 4, 4 minus 1, 4 plus 2, and then 4 minus 3. 3, 6, 1, so 18. Okay, and so now we're going to graph this. You can make this part as detailed as you like. You will have some very extreme values at times. So you may just want to graph this generically. So -3, -24. So we know that's going to be all the way down here, maybe somewhere. And if you want to point out what are the coordinates, you can. Next we have the 0. Next we have -1, 8. Okay, so -1, 8 might be like around here. Two, -4, probably be about here. And then 4, 18 will probably be about here. Okay, and so if we follow the general trend of these points, this is more or less an approximation. Okay, if you use technology, you would see it's going to be something very similar. Okay, it would look like that. Okay, notice this is if we focus on the leading terms of each of the factors, x times x times x, this is going to be an x cubed. Okay, so in an x cubed, you'll have the two turning points, which we see here, and it'll have the same look to it with a leading coefficient of positive. Okay. This is probably one of the easier examples. The factors, they're already given to us. We just have to identify the zeros. And then do we identify y-intercept? Probably would help. Y-intercept, if we plug in 0, let's plug that in. So if we have 0, f of 0, 0 minus 1, 0 plus 2, and 0 minus 3. So -1, +2, -3. So it ends up giving us a +6. Okay, perfect. And so we have our y-intercept as well. Okay, let's go on to our next example. Okay, same idea. It's a polynomial. We're going to try to identify zeros, y-intercept, and graph. So for starters, when we see 4 terms, we try to factor. Okay, that's generally our first rule of thumb. If it doesn't factor, then we try something a little more creative known as the rational root theorem. Okay, and the rational root theorem tells us that we look at our constant term. Okay, we're going to designate that as P. And then we look at the leading coefficient. Leading coefficient, that's going to be Q. And so now what we do is we find the factors of P and the factors of Q. And you do this with positives and negatives. And then we're going to look at a final quotient of P over Q. And that'll give us potential rational roots for this particular polynomial. Okay, potential. So factors of P. So P is 4. So we do factorization of 4, we know we'll have, of course, plus or minus 1. 2, right? 2 goes into 4 evenly, so plus or minus 2. And itself, so plus or minus 4. For q is 3. Luckily, it's a prime number, so plus or minus 1 and plus or minus 3. Okay, so now let's do the quotient of p over q. Okay, so take each of your p's and you divide it by each of your q's. So let's say we had the 1. So this would be 1 divided by 1. So that would be plus or minus 1. 2 divided by 1. So that would be plus or minus 2. And then 4 divided by 1. That would be plus or minus 4. Okay, next we could take our 1, 2, and 4 and put it over 3. Okay, so plus or minus 1 over 3, so 1/3. 2 over 3, so plus or minus 2/3. And then 4 over 3, so plus or minus 4/3. So what we're saying is each of these possible numbers is a potential 0. Okay, again, this is all part of what we call the rational root theorem. If you want to look that up on the side, I'm sure there's plenty of videos that explain a little more in detail. But this is what we're doing here, rational root theorem. So now, what I would suggest, you're going to try to pick out a possible rational root here. Okay. Now, it helps to always start simple. I like to start with plus or minus 1, plus or minus 2. I like to take advantage of the whole numbers first. And we're going to try to break down the original polynomial with a little synthetic division. Okay, so if let's say we want to test if 1 is a possible root. Okay, if 1 is a possible root, that means we would put 1 in the box for our synthetic. And then we would list out our coefficients. 3, 8, negative 15, 4. 3, 8, negative 15, 4. And so if 1 is indeed a rational root for this polynomial, we should get a 0 remainder. Right? So let's see if that's going to work out. Okay, remember in synthetic we copy down the first coefficient. And now we multiply the number in the box with that first number that came down. So 1 times 3, 3. And then we add 8 plus 3, 11. 1 times 11 is 11. Add negative 15 plus 11, negative 4. 1 times negative 4 is negative 4. Add 4 plus negative 4 is 0. Perfect. Okay. That's what we wanted to get. Okay, 0 remainder. Now, if you didn't get a 0 there, then you try something else. Maybe you try negative 1. And maybe then you try 2 or negative 2. But you keep trying until you get a 0 here. And then that allows you to break down the polynomial. Okay, so right now, this is what our polynomial looks like. Because of the 1 there, that means x minus 1. Okay, if we write it in a factored form, x minus 1 would be the 1 factor. And then we started with the x cubed. And if we do synthetic, remember we just drop the powers by 1. Okay, so x cubed becomes x squared. So the leading coefficient here is an x squared. So 3x squared plus 11x minus 4. Okay, and so now if all things go well, we try to factor this quadratic. Okay, hopefully that factors. Okay, in this case, we could do this with AC method. 3 times negative 4 So that means that will give us a negative 12. What multiplies to negative 12 and adds up to positive 11. So we have 1 and 12, 2 and 6, 3 and 4. To give us a positive 11, we would do, for example, negative 1 and positive 12. Okay, so negative 1 and positive 12 is a positive 11. We can break down that quadratic. Just give us our two numerators of 3x, 3x and 3x. Write down the two numbers we thought of underneath. Okay, the 3x and the 1, they don't reduce, so that's one of our factors. The 3 and the 12, we could reduce there. That's a 1 and a 4. Okay, so we have x minus 1, 3x minus 1, and x plus 4. Okay, and to solve for the zeros, again, now it's in a factored form. Set this equal to 0, and now you could solve each one. Right, so we have zeros at positive 1. Add 1, divide by 3, so 1/3. And minus the 4, so negative 4. Okay. What else we need? Y-intercept. Y-intercept, we could plug in the 0. Remember, it's easier to plug it into the original. In this case, 0, 0, 0, plus 4. So y-intercept of 0, comma 4. Okay, so now we can get ready to graph this. Again, we'll set up our sample graph. X-axis, y-axis. Identify the zeros. So we have 1, 1/3, and negative 4. Okay, negative 4 is over here. 1 is over here. And then 1/3 will be like over here. Okay. So, again, we want to get a point to the left of the leftmost 0. So left of negative 4, we have negative 5. Let's make our table. We have negative 5, and now let's do negative 3. We did 0, 4, so we know that one. And then between 1/3 and 1, we could pick a convenient value, as convenient as possible, 1/2. Okay, and then after 1, we could pick 2. Okay, so now let's plug these into our function. Probably easiest to plug it into the factored version. Okay, so we have, so f of negative 5 So we have negative 5 minus 1, and then 3 times negative 5 minus 1, and then negative 5 plus 4. So negative 6, negative 15 negative 15 minus 1. It's negative 15 minus 1, negative 16. and negative 5 plus 4, negative 1. Multiply it together, that's 96, negative 96. Okay, plug in negative 3. Negative 3 minus 1. 3 times negative 3 minus 1. Negative 3 plus 4. So negative 4. Negative 9 minus 1, negative 10. Negative 3 plus 4 is a positive 1. Positive 40. Okay, a half. So a half, that would be a half minus 1. Be extra careful on this one because now we're dealing with fractions. 3 times a half and a half plus 4. Half minus 1 is negative 1 half. 3 times a half is 3 halves. 3 halves minus 1. So 3 halves minus 2 halves is 1 half. And then 1 half plus 4, that's 4 and a half. Right, that's 4 and a half, which we would make that 9 halves. Okay, so that gives us a negative 9 over 8, so negative 9 eighths. Okay, and then 2. 2 minus 1. 3 times 2 minus 1. And then 2 plus 4. So 1, that's 6 minus 1, 5. And then 2 plus 4 is 6. So positive 30. Okay, so now let's graph it. Negative 5, negative 96. Negative 5, negative 96 will be way down here. We have the 0. Negative 3, positive 40. Okay, so negative 3, positive 40. And then we have our y-intercept, 0, 4. And then we have a half, negative 9 eighths. So that's going to dip just below x-axis. Half, negative 9 eighths. And then 230. 230. Okay, so this is how it would look in general. Again, this is an approximation. Okay, and it would look more or less like that. Okay, let's take a look at our next one. Okay, let's graph the function, identify zeros, and the y-intercept. First option should always be the factor. Okay, notice I see a common x between them, common x squared in fact. I can pull that x squared out. Okay, that means I'm left with x squared minus 5x plus 6. Okay, and then from here I could factor out the quadratic. So I have x squared multiplies to 6 and adds up to negative 5. So it looks like we would have x minus 6 and x plus 1. Okay, and so we're ready for zeros. Be careful with the x squared. Some people often forget about that one. You just set the x squared equal to 0, and you get x equals 0. Okay, so be careful for that one. Or even if you have just a plain x. It happens to be a common mistake people make. They forget about that one as a factor. X minus 6 equals 0, so x equals 6. And then x plus 1 equals 0, so x equals negative 1. Okay, so we have our zeros. So we can set up our graph. Let me redraw this one. Okay, so we're going to label our zeros. Okay, so we have our negative 1, 0, and 6. Okay, so like we did with the other ones, we're going to pick values that are to the left of the leftmost 0, between any zeros, and then to the right of the rightmost 0. Okay, so let's go through it. Let's plug in let's create our table. So to the left of negative 1, we have negative 2. In between negative 1 and 0, we have negative a half. After 0, we have positive 1. Before 6, we have 5. And then after 6, we have 7. Okay, so we have our functions now. We're just going to plug into the factored version. So f of negative 2, that means we'll have negative 2 squared, negative 2 minus 6, and negative 2 plus 1. So positive 4, negative 8, negative 1. Positive 8 times 4, so 32. Okay, negative 1/2. Plug that in. Okay, so positive 1/4. Negative 1/2 minus 6, that would be negative 6.5, so negative 13 over 2. And negative 1/2 plus 1 will be a positive 1/2. Okay, so this gives us a negative 13 over 16. Okay, next let's plug in 1. Okay, 1 squared is 1. 1 minus 6, negative 5. 1 plus 2 is 3. multiply it together, we get negative 15. What did I? Hold on, I think I just did a blunder. It's supposed to be 1 plus 1. Good thing I caught that. So that'll be corrected version, negative 10. Okay. F of 5, 5 squared, 5 minus 6, and 5 plus 1. So 25, negative 1, 6, that's negative 150. And then 7, 7 squared, 7 minus 6, 7 plus 1. So 49 times 1 times 8. So that'll give us 392. Okay, so let's graph this then. So negative 2 and 32. Negative 2 and 32. Next we have the 0. Negative a half. That would be negative 13 sixteenths. So that would be about, let's say, there. Okay, and then we have after that we have 1. 1 is negative 10. Five, negative 150. Okay, 5, negative 150. Six, we know is the 0, and then 7, 392. So 7. Let's make it up there. So 7. Okay, so let's connect them. I was interested to see what happened around 0, because notice we have an x squared there. And you'll learn more about this as you go on to future math classes. But when we have an x squared, that talks about our multiplicity, right? The multiplicity of an x squared factor would be 2, right? So anytime it's an even multiplicity, long story short, the graph doesn't go through the 0, but it touches and bounces off. Okay, so that's what we'll notice there. So we'll have it come down, goes through. At the 0, it'll bounce off, it won't go through. Okay, for this point, this should be a lot further down. I just kept it like this, just for simplicity's sake. And then it's going to bounce up from there, take a sharp trajectory upward, and go through there. Okay, and this is a fourth degree. So, right, fourth degree. Remember, it'll be a polynomial. Will look kind of like a W, right, when it's a positive coefficient, positive leading coefficient. And then if it's a negative leading coefficient, then it should look more or less like a M. Right, but as x goes to infinity, the function should go to infinity. As x goes to negative infinity, functions should still go towards positive infinity. Okay, so that's about it for our polynomial section. Okay, I will continue with the rational function section in the next video. Okay, have a good day, have a good night. We'll see you soon.